back, students. We'll continue with the programs of 8085. Okay, the first program that we're going to see here is a block of data is stored in memory location starting from D1001H. The length of the block is stored at D1000H. Write a program that searches for the first occurrence of data 06H in the given block. Store the address of this occurrence in HL pair. If the number is not found, then HL pair should contain FFFFH. Okay. In this program, the data are stored from D1001 onwards, and how many data are there? That block length is stored in D1000, and the program is going to search for the data 06H. If the data is found at some place, that address has to be there in HL pair. If you find nowhere the data in the given block, then the HL pair should contain FFFFH. That is what is the meaning of this program. Okay. So the logic of this program is just the comparison, where you start comparing the data which is there from D1001 to D1000 whatever, depending upon what is stored in D1000. We are going to compare each and every data. Whenever you find that there is a equality in the comparison, means when the zero flag is set, then we are going to say that the data is found at that place and we are going to end the program. So the program goes like this. Point to the first memory location D1000, take the data to C register and let the accumulator contains 06H. After that, you go to the next memory location, which is D1001, which is the starting address of the data, and then that data, which is a memory data, you are compared with accumulator, and then if that both the datas are same, then zero flag is set, and then you are going to end the program. When you end the program, HL pair is already having the content, that is the address of that location. If not, means what? If the contents are not same, then jump on 0 to down is not true. It is going to continue. So you are going to go to the next memory location. So how do you go to the next memory location? By decrementing the counter and jump on no 0. If the counter is not 0, you're going to go back and go to the next memory location. So in this process, you go on doing continuously the incrementation, compare, and then if not 0, then go to the next memory location. So when you see that you have done with all the data bytes, when the register C becomes 0, means what? There is no data which is there. There is no data 06 in the given block. Then HL pair we will store with FFFF by using LXI HFFFF, and then we are going to stop the program. Okay. Now the next program that we're going to see is the division program. Write a program that divides two 1-byte hex numbers, where dividend is stored in memory location D1000H and divisor is stored in memory location D1001H. Store the quotient in memory location D1002 and the remainder in D1003 respectively. So as we know, the subtraction is the logic that we are going to use for division, as we don't have any division instruction directly. So division is nothing but successive subtraction, as we know that multiplication is successive addition. Okay. So as many times you subtract, so you're going to increment a counter. One time subtraction, you're going to increment 1. Second time subtracted, then you say 2. So that number of times subtraction gives you the quotient, and when the contents of accumulator is less than the contents of the memory, then you are done with the subtraction. So whatever is there in accumulator will be the remainder. Okay. So the logic of the program goes like this. LXI D1000H, move the contents of content 00 to C register, that is MVIC 00. Whatever is there in memory, that is the first data byte, you store it in accumulator. Go to the next memory location, compare with it, and then compare with what? You are comparing the first content with the second content, and then if that content itself, the first content itself is smaller than the second content, we are not going to continue the subtraction, because you are doing subtractions like 2 divided by 3, which we don't do, or where we don't have any fractional decimal result here. So we are going to stop the subtraction, or stop the stop doing any further processing. Okay. So here, after comparison, if the carry flag is set, means what, accumulator is smaller than the memory, then you are going to go to the next memory location. Whatever is there in C, you are storing in memory, and whatever is there in accumulator, you are storing it in memory, which is the next memory location. So there ends the matter of subtraction, or you can say there ends the matter of division. So once, if such data are given, then it is going to go like this. If you have a data like 9 divided by 2, so you are going to subtract 2 from 9. How many times? You are going to do it for 4 times. Okay, so how this 4 times subtraction goes is, you take the data, after comparison, jump on carry is not true, you are going to do subtraction. Subtract memory. After subtraction, you are incrementing C, because I say that it is one time subtraction, and then go back to compare. Again, the contents of accumulator and contents of memory are compared, and then again you're going to say jump on carry to loop. If at all here itself it ends, then you're going to go out of the loop, or else you go to subtraction, increment C. So this goes on repeating how many times, till the accumulator contents become smaller than the memory content. Once the accumulator contents become smaller than the memory content, you're going to jump to the instruction called INXH, and whatever is there in C, you are storing it in memory location. Now what is there in C? How many times you have subtracted, that is the data. What is that? It is the quotient. Okay, that data is stored in memory, and go to the next memory location and store the accumulator to memory. What is that? That is the remainder, and then you are going to end the program. Okay. Okay, the next program is write an assembly language program to add two 8-bit BCD numbers stored at memory location 5000 and 5001. Store the result in memory location 5002 onwards, starting with least significant bit. So it is just a BCD addition. So what is there in BCD addition? After addition, you have to adjust it to the decimal way using decimal adjust accumulator. So the instruction goes like this: LXIH 5000, move immediate C00, move the contents of memory to accumulator, increment HL pair, add the memory. After addition, you are changing the hexadecimal to decimal by using decimal adjust accumulator. If in this adjustment, if there is a carry generated, then you are incrementing C register. If not, you are storing the result in 5002, and whatever is there, suppose carry has been generated, that data you are taking to accumulator and storing it in 5003 and ending the program. Okay. The next program is to count number of even data bytes occurring in a block of data starting from 3001 and onwards. The length of the block is stored in 3000 and the result to be stored in 3100. Here you are finding out the even data byte. So the logic of finding out even or odd is the last bit of a number. If the last bit of the number is 1, then it is an odd number. If the last bit of a data byte is 0, then it is an even number. So, depending upon whether you are getting 1 or 0 after rotation into the carry flag, you are setting it as even or odd. So, that is the logic that is used in this program. Rotate and check. First instruction, LXI H3000. Point to the first memory location. Take B with 00. Whatever is there in memory, take it to C register. Go to the next memory location. Take that data into accumulator and rotate it once to right. So if you rotate it left, it is not going to give you the result, because it is the last bit which is, if you rotate it left, which is going to go out, which is not going to give you the result. Okay, which is the first bit which we need to take out, so that if it is 1, you are saying it as odd. If it is 0, you are saying it as even. So rotate it right, jump on carry to ahead, otherwise increment B register, and then decrement C, jump on no 0 to loop, means you're going to go to the next memory location. If carry is generated, means what? It is an odd number, so we are not incrementing B. Means what? The content of B says how many even data bytes are there in the result. Okay, so as you repeating this, at the end, whatever is there in B register, you are storing it in 3100, which says these many number of even data bytes are there in the block. Okay. Okay, the next one is a hex number is stored in memory location 3000. Write an assembly language program to interchange its digits. The new number is to be stored in 3001H and the original number and the new number to be added and stored in 3010. So how do you exchange the position of the digits is by rotating it 4 times. Once you rotate it, whatever is the original data, you add it and store the result. That much is the logic. So it goes like Alexa H3000, move the contents of memory to accumulator, rotate the contents of accumulator 4 times. Then increment HL pair, whatever is there in the memory, whatever is there in the accumulator, which is the shifted digits, will be stored in memory location, which is 3001. Again, decrement HL pair means you are going to 3000 because you want to add 3000 data with the shifted data, or you can say swap data. So going to the previous location and adding M will add the contents of 3000 and 3001, and the same data which is there in accumulator is stored at 3010 using STA3010, and then end of the program. Okay. Now the next program is write an assembly language program that separates two nibbles of an 8-bit number stored in memory location 8000, store the same in memory location 8001 and 8002, and this program also multiply the two separated nibbles and product should be stored in 8003. So the meaning of this program is if you have data as 45H, you are separating it as 04 and 05, and also you are multiplying this 04 and 05 and storing it in 3003. That is the implementation that we are going to do in the program. So the instructions are Alexa H3000, move the contents of memory to accumulator, and immediate with 0fh. When you AND with 0fh, what you get is if you have 45h as the data, after ANDing with 0fh, you get 05h. And then move the contents of memory to accumulator, and with f0 means what? Now you get 40 as the data. RRC, 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 RRC means 40 are rotating 4 times, you get the data as 04. So you have separated and you have got the result as 05 and 04. Now whatever is that data, you are shifting to C register, incrementing the HL pair. Whatever is there in B register, you are shifting to a memory location, the next memory location, and whatever is there in C register, that also you are moving to the next location. And then once you put it in the consecutive memory location, the separated nibbles, now you are subtracting accumulator with accumulator to make accumulator 0, so that the addition of B with accumulator first time is happening. So add B and then decrement C. Jump on no 0 to loop means you are repeatedly adding the contents of B to B. How many times? You are adding it C number of times. Once the C contents become 0, you get the product in accumulator. The same accumulator contents are you are moving it to the next memory location, which is D1003, and stopping it. Okay. So the next program is write a program that to count the number of times data H. What is the data? ADH is found in the block. So it is like last time we have done this program, how to find out the content 06 in the memory location. Here it is to count. Last time it was first time when it has occurred. Here it is how many times it is occurring. So as many times it occurs, it is you are going to say one time it has there in the block, or 9 times it is there in the given block. So depending upon how many times it has occurred, that we are going to display here. Sorry. Okay, the program goes like this. Move immediate B00 LXIH to FFFH. What is there in 2FFF? It is the counter. Okay, so the same counter you are taking to C register, incrementing HL pair. Whatever is there in memory, you are shifting to accumulator, and you are comparing the accumulator content with ADHH, because that is what the data we are finding out. If that data is also ADHS, means what? One time the data has occurred. If both the data are same, 0 flag is set, and then you're going to increment B. If not, you're going to go to the next memory location. So before going to the next memory location, you say that I have done with one time comparison. So that's why we are decrementing C and going back to increment HL pair. So this loop is repeatedly happening till C becomes 0. Once C becomes 0, we have P content as the number of times ADH is there, and that data you are shifting to accumulator, and from accumulator you are storing it in 2000H and then ending the program. Okay. Okay, now there is a program called subroutine. Write a subroutine to fill the location 2800H to 28FFH with X number 00 to FF respectively. So here you can see the program is a normal program, but it is asked to write a subroutine. So we are ending this program by RET. If you end the program by RET, it becomes a subroutine. So the program is LXID 2800 and you are exclusively ORing accumulator. The accumulator means what? You are clearing the accumulator, taking B with FFH, and then whatever is there in accumulator you are shifting to 2800. What is there in accumulator at this point is 00. So 2800 is put with 00H. You are incrementing A register means what? Accumulator now is 01. You increment E register means E register has 00 because DE pair has 2800. If you increment E, it becomes 2801. Now you decrement B. What is decrement B? FF will become FE, and then jump on O0 to store the data of accumulator to D register. So you have incremented to 2801, accumulator has 01, so 2801 is taking data as 01. Like this, you go on incrementing the data in accumulator and also going to the next memory location. So it will store 2800 with 00, 2801 with 01, 2802 with 02, like that, 28FF with FF data, and then you are ending the program by RET, not with HLT. Okay. Okay, with this, we are going to come to the end of the program. So in this section, we'll continue with some more programs in the next section. Thank you.